Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. My name is Zubair Yahya, and I am here presenting our research titled Design of Application Framework for Vital Sign Monitoring and Remote Doctor Consultation, collaborating estimated researcher Muhammad Reza Faisal, Radityo Adi Nugroho, Indi Parmadi, Dodon Turanto Nugradi, Rudi Herteno, and Pina Yulia Anhar. Let's delve into the introductions of our research. We'll begin by explaining the first domain, vital signs monitoring. Vital sign monitoring involves the use of medical monitoring devices to measure and track patient essential indicators, such as blood pressure, heart rate, body temperature, and more. The next domain we'll explore is remote doctor consulting, where patients can seamlessly connect with doctors through telecommunications technologies such as video calls, voice calls, or text messages. The background of this research is rooted in the lack of connected patient vital signs monitoring system through medical device in Indonesia. While teleconsultation system exists, there's a gap in the infrastructure preventing real-time remote monitoring of patient vital signs. Our research aims to bridge this gap by constructing a telehealth application framework that not only facilitates remote doctor consultation, but also enable real-time monitoring of patient vital signs from a distance. Now let's jump into the methodologies of our research. The first phase is identification of problems. Next is feature-oriented domain analysis. And the last is design with hotspot-driven. We begin by identifying core issues in the telehealth through in-depth literature review. This groundwork provides crucial insight for our subsequent step. Our data collection process was meticulous, providing a robust foundations for our research decisions. Feature-oriented domain analysis is a software a domain methodologies to systematically approach, use, and analyze software domains to identify essential features required by various stakeholders. This phase involved app review, context analysis, domain modeling, and architecture modeling. We synthesize existing applications, analyze contextual factors, and meticulously model the domain and architecture. In the last step, we using design with hotspot-driven approach by identifying key hotspots from our analysis, which shapes our design process. Our design centered around these vital elements, ensure that our framework is not only technological advanced, but also user-friendly and adaptable to diverse healthcare scenarios. Now let's jump into the result of our research. The first is data collections. Our data collection process involves analyzing data from various applications within each domain, focusing on those widely used and highly rated. By meticulously evaluating user-friendly and popular platforms like Halodoc, HaloDokter, SehatQ, MedM, VitalConnect, and BioBit, we gathered valuable insight. This data-driven approach was instrumental in shaping our telehealth application framework, ensuring its relevance and effectiveness. Through our analysis of Halodoc, HaloDokter, and SehatQ, we pinpoint 9 essential features within remote doctor consultation domain. Simultaneously, in MedM, VitalConnect, and BioBit, we identified 5 key features in the vital sign monitoring system. Understanding these core features empower us to enhance our telehealth application framework. Context analysis is a vital step in understanding the environment in which our application operates. It involves dissecting user interactions and identifying key actors. In our case, the context diagram visually represents this understanding. Within this diagram, we recognize 3 actors. There are visitors, patients, and health workers. Each actor possesses distinct features tailored to their needs within the application. Next is domain modeling phase. We translate the initial 14 main features into 19 detailed framework unique features. This comprehensive breakdown allows us to understand the intricacies of our telehealth application. On this slide, we present the primary domains, the hotspot, and frozen spot. In this slide, we present a detailed table outlining the frozen spot classes. There are 16 in total, and the hotspot classes 6 in total within our telehealth application framework. Frozen spots symbolize the stable and unchanging element that ensure consistency and reliability in our system. Meanwhile, hotspots represent the dynamic, innovative feature driving the evolutions of our application. This classification serves as our roadmap, guiding the development process and ensuring a balanced blend of stability and innovations in our telehealth solution. Moving on, in the use case diagram crafted from our functional analysis, on this slide, our focus is on account management within our telehealth platform. In this diagram, we showcase a series of essential features related to account management. In the use case descriptions, you can see the conditions and the flow for register account. And in the activity diagram, you can see the process of the register account, starting from the clicking the button and the system saving the registration data. On the following slide, showing partial representations of the formulated hotspot card without sign input and notification. This hotspot serves as focal points within our telehealth application, ensuring seamless vital sign monitoring and effective communication. In this slide, our architecture is structured into two essential layers, the base framework and the domain-specific component. This design ensures a streamlined and efficient telehealth ecosystem. The base framework serves as a foundation of our telehealth system. Within the domain-specific component layer, we address the unique requirement of telehealth service. In this slide, we present two vital class diagrams resulting from our hotspot analysis, vital sign input and notification. This diagram encapsulates the heart of our hotspot-driven design methodologies, demonstrating the intricate relationship and functionalities within our telehealth application. Both diagrams showcase the classes. There are vital sign class, consultation class, and patient class. In the notification hotspot, we introduce the observer class, enhancing our notification system. The observer class is seamlessly integrated in the vital sign class and triggered based on real-time vital sign data. This real-time feedback enhances user engagement and promote proactive health management. In the vital sign data, we introduce two variabilities classes, one accommodating wearable device and the other managing form-based data. By accommodating both, telehealth system offer flexibility in collecting vital sign data. Now let's jump into the conclusion of our research. A comprehensive application framework can be developed through the analysis of two distinct domains. The analysis results in 14 main features and 45 sub-features. Out of the 45 sub-features, 16 were implemented as frozen spot, while 6 were implemented as hotspot. Among these, 3 sub-features use the strategy design pattern, 2 use the observer pattern, and 1 utilizing the filter pattern. The limitation of this research lies in the fact that there are only 6 hotspots representing sub-features. The scarcity of hotspots renders the application framework less flexible in accommodating diverse software development. In the future work, the application framework will be examined through the development of the final application. Effort will be made to enhance the application framework progress to ensure the inclusion of essential functions. This approach aims to create a versatile application framework that can be easily shaped and expanded by the software developer. This brings me to the end of my presentation. Thank you for your attention.
Okay, thank you, Mr. Zubairi. Okay, next we will go through the Q&A session. Is there any question about the Mr. Zubairi Yahya presentation? Please ask the question if you have.
Recording in progress.
From all of the participants. Okay, maybe I want to ask a question to Mr. Zubairi. What is the most difficult or challenging step in your research?
Okay. For the most challenging step is connecting the real-time data of the IoT device, wearable device, into the application, because we use already product device that you can buy in the store, and we break it down so it can be used in our application, so it can meet the requirement in our application, and combining it with remote doctor consultation quite hard because we cannot connect it directly like a system like SIG system in the hospitals, and it's hard to connect the wearable device into it. That's the most challenging part.
Okay, but uh, did you consider that broke the product non product can be a problem in law, maybe breaking the law. For example, the product is closed or non open source, something like that, and you make a modification. Is there is that okay?
Okay. We use the wearable device because when we make the device, it's really big, so it can be used in the end user. So for it to be used in the end user, we use product that are already in the market. It's for the research purpose only, so we can know the research how it can be used in the real time situation.
Okay, thank you. Is there any other question from the other presenter, maybe?